Okay, so writing the 45, 45 triangle, let's put it here. How do I do that? Okay, no, I'll leave that somewhere else. It's a 45, 45. What do we know about the sides of a 45, 45 triangle? They're what?
Equal.
They're equal. And so these two are equal. This is in, 45, 45. And then what would the hypotenuse be?
n√2.
Good. Okay. So we could go through and do all the 45, 45 triangles, or we could just do them in order. How many of you would prefer to go through and do all the 45, 45 triangles first? So we'll go through and do all the 45, 45 triangles first. So labeling, don't forget to label. So we have n, and n√2. And I'm not going to write x and y equal, and I'll leave that for you. But so what would this side over here be for y?
N.
Okay, but what is n?
I mean 9.
9, good. So this side is 9. What does that make the hypotenuse then?
9√2.
9√2. And you're done. Okay. So the chat button's now been operational. So on this one, we label n, n√2. So in the chat box, go ahead and put what the other leg or n would be. Go ahead and put in the chat box what this would be and what the hypotenuse would be. So write the leg and then comma the hypotenuse. This is a little more tricky. This is the whole value. Okay, I thought I disabled the chat to everyone. Can you guys just put it to the host, please? I'm gonna, because I can see everybody's responses and I need to make sure it's only to me. Okay. Thank you for the I'm not sure. Okay, thank you. Okay. Jose, go ahead and simplify that for me. Okay, good, Gianna. Okay, many of you got the N. Okay, Genevieve. Okay. Good, Aiden, good, Andrew, nice. Okay, so a lot of you got those, but some of you are still not real sure. So this being in, wherever I see an in, I'm gonna put it on the other side, okay? So that would make, these are gonna be equal. These are always equal. So this is 5 root 2, this is 5 root 2. Done. To find n, we're going to substitute it right there. So my m is going to equal n root 2, but n is 5 root 2, and then I bring down the root 2. So what do we know that root 2 times root 2 is? Anybody?
Just 2.
It's 2. We have an outside 5 times an outside 2, which is going to equal 10.
I did it different.
Okay, how'd you do it?
Well, I times 2 times 2, which I got 4, and then I put 5 square root 4, and then I did the 2, and then 5 times 2. Is that like the same thing?
Absolutely. Yep. Yeah,
So-
and a few people put 5 root 4, and so I said go back and simplify because the square root of 4 is 2. That's awesome. Yep, that works. This just cuts down on one step, but it's totally the same thing. So that was very good. Okay, so number 3. I know I have a line in my paper. Okay, so labeling n, and n root 2. Okay, so there were a few people that said they weren't sure. So let's see if we can help a few people here. Okay. And I really do appreciate. So we know that the sides are equal, but we need the actual n value. Okay, good. Some of you are already ahead of me. If this is n root 2 and this is 3 root 2, do I know what n is?
Yes.
Okay, how?
Because you write n root 2 over 3 root 2, so 3 is in the space of n.
Perfect. Yep. I can kind of, do something like that because they're the same. And so I know that n is 3. So I know that this is 3. And because I know that these are equal, that side is 3. Done. Okay. The number 4 is a 30, 60, 90. Number 5, 6. So we'll jump down to number 7.
I have a question.
Yes.
On number 3.
Mm-hmm.
Why wouldn't you times 2 times 2 if they're both square roots? Or like, you know what I'm saying? Like how we did on the other one, how we just left it as like 2. Like why wouldn't you times 3 times 2? Or you know what I'm saying?
Yeah, that's a really good question. Because the other one we were given the side had a root 2. So when we plugged in a root 2 in for n, that means if I know, okay, so let me do it backwards. If I knew that n was 3, I would simply substitute 3 in for n, and I would get 3 root 2. So when we do it the other way, and if this were, let's say, like we did before, 5 root 2, then I plug in that number directly for n. So going back, like over here, because my n had a root 2, this whole thing was n. So I needed to substitute that whole circle, that whole number in that circle. And when I do that, I have to multiply. Does that make a little more sense?
Yeah, thank you.
You're quite welcome. Okay. So we jump to number 7. Okay. So same idea, labeling with n, and root 2. So put in the chat box what n is, what the number n would be. Okay. Good. Okay. I have a lot of answers, and I had a question mark. So, okay. Most of the right answers and a couple, not quite. So let me call on a few people here. Gabriel. So when I'm looking at what I'm given after I label, and I'm looking at the comparison, I'm looking at this part right here. I need to find out what my n is. If they both have a root 2, then I'm simply going to select the number next to the root 2 to be my n. So in this case, n is just 5.
Oh, okay.
Okay, because it's kind of like I can say this root 2 is the same as that root 2, which just leaves me n is 5. Okay. So there's a couple people that said, I'm not sure. Can you put, or had a wrong answer. Can you put in the chat box now if you understand? And if you got the number 10, I see where you got the 10, but I'm really hoping that, okay. Okay, good. 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 That's why labeling is so important, because when we have something like this, it's a matter of looking at the relationship and going, oh, well, if this has a root 2 and that has a root 2, then it's like covering this up and going, my n is 5. And so that would make this 5 and this 5. Okay. Okay. Thank you for letting me know about your internet. Okay, turning the page over. Okay, jump to number 13. So we have n, and n root 2. So give people a chance to catch up. So my question here is, can I look at this comparison to do what I did before and know and say n is 10? What do you guys think? Anybody brave enough to say it? Is n 10?
No, it's not.
No. Okay. So what would, okay, so if it was 10, then this would be 10 and that would be 10 and that would be 10. That wouldn't work because they're different. So this is where I need to go back and say, if my number that should have a root 2 doesn't have a root 2, then I need to use the shortcut. So we're going to put SC for shortcut. The shortcut for this triangle is our root 2 over 2. So we're going to say that to solve for n is equal to whatever number that is, the root 2 over 2. what was the value of my hypotenuse? What's the value of the one that should have had a root or could have a root 2 and didn't?
10.
10. Okay, so I'm going to put this number in place right here. And that's 10. And then I simplify. Then simplify. Okay. If that were a 7, I would be done. But the bottom 2 goes into the top 10. And what do we get?
5 root 2.
5 root 2. And you're done. That was it. So this is important. And if you need to, write this down on the side of your paper. Okay. We wrote it yesterday and we wrote it the day before, the class before. If your number that should have a root 2 or root 3 does not have a root 2, then you need to use the shortcut.
I have a question.
Sure.
How did you find 5 root 2?
Once I put this number in to my circle, then remember we do outside numbers together and inside numbers together. This bottom 2 goes into the 10 5 times.
I still don't get it.
Okay, so if I have 10 over 2, what does that give me?
5.
5. So if I add a root 2 next to it, this is still going to give me 5, and then I'm going to keep the root 2. Because remember, these are outside numbers and this is an inside number.
Okay, that makes more sense. And then I have another question.
Okay, yes.
How do you know when to use the shortcut, like during an example?
So there's only 2 parts to our 45 triangle. One is in and the other is in root 2. I know I don't like that line there. When you're in root 2, does not have a root 2. Now let me explain what I mean by that. Let me flip this over. See how number 7 had a root 2. This in root 2 has a root 2. So I can look at the number next to it and know that that's in. When you're in root 2 does not have a root 2 next to it, that's when we need to use a shortcut.
Okay, thank you.
You're welcome. So in this case, when I looked at number 13 and saw that my 10 did not have a root 2 next to it, and it could have been anything, it could have been a 10 root 6. Okay, it does not have a root 2, then I know I need to use a shortcut. Awesome. Okay, so moving on. Moving on to number 15. So we label in, and in root 2. So let me give you a second to do that. Write down what you think the other side of your triangle is going to be, which is in or y. And then find the hypotenuse in root 2 or x. And put that in the chat box. And if you are still unsure, I need to see like an IDK or not sure or something, because I need everybody's participation. There's 24 of you. You only want to meet. Okay. I really appreciate the feedback because I'm seeing that more people are not sure than those that are. So I'm going to go back. Let's see. Okay. Okay, we're gonna do a sidetrack here for just a second before I finish this problem. So give me just a second. We're gonna do something. We're gonna go back and we're gonna look at this for a minute. We're gonna do a couple of example problems because I don't want to leave anybody behind. This and trig functions are probably two of the key takeaways from geometry that you need for math later. Okay. So we're going to look at the 45 triangle. So this is going to be n, and n root 2. So let's kind of do a compare and contrast thing here real quick. What do they all have in common?
All the sides equal each other.
Not all of them.
2 of them.
2 of them are equal. Okay, so 2 of them are exactly equal. And then what about that third side? The hypotenuse. Does it have anything in common with the other 2 sides?
It has an N.
It has an n. Okay, so we know that these 2 sides are exactly equal. But we know that n, they all share an n. This has an n, this has an n, and that has an n. So if I tell you that, I really don't like that line there. Okay, so let's just do a quick one over here. If this side is 3, what is this other? So n, and n root 2. What is this other leg going to be?
Three.
It's 3. They're equal. So this is 3. So how do I find the hypotenuse?
You just fill 3 into n because n equals 3.
Okay, and then the final answer would be what?
3 root 2.
3 root 2. Thank you. So I'm going to put this in, because they all have an n. I'm going to put this number in place of n and put a root 2 next to it. And that's it. See? So let's do this one. Move it over here. Let's call this one 12 root 2. So I'm going to label n, and n root 2. What did we say they all have in common?
The n.
The n. See? They all have the n in common. This one, and this one. So when this is the number in front of my root 2, what do I know n is?
12.
12. So because these numbers are all going to be the same, I know that n is 12. Okay. So put in the chat box, did that help anybody, this exercise? Because there's two other types that we need to do. Okay. Okay, good. Now, these n's are all the same, but sometimes they're not a nice integer. Sometimes they'll have a root with them. So if it has a root, it's still the same idea. Okay. And I notice if you don't get the ones that are a little more challenging, at least be able to do the 2 that we just did. Okay. And you'll be probably 75% of the way there. Okay. But we're going to call this one 6 root 2. We have n, and n root 2. But what did we say they all have in common?
The n.
The n. Okay. So this is my n, that's my n, and that's my n. So this is the number they're all going to have in common. So what does that make the left side?
6 square root 2.
6 square root 2. Okay. And what do I put in place of that n?
6.
No.
Oh, is it 6 square root 2 times square root 2?
Yep. Because this is the same n that goes right there. So this one takes one extra step because this is n. And then I have to put the root 2 next to it. Okay. So what do we get with root 2 times root 2?
Just 2.
That's 2. Good. Or we get square root of 4, and the square root of 4 is 2. They get a 6 times 2, which is 12. Okay. So wherever we see an n, I'm going to put the number that they all have in common. Now this could have been a 6 root 5. If I had a 6 root 5, I would have just multiplied those together and got a 6 root 10. So don't stress on that. It doesn't have to be a root 2. And I think this is a really good exercise because this will help us with our 30, 60, 90s also. Okay. So we've got n, and n root 2. This time though, I'm going to say n is 3 root 5. So what does that make? Oh, I'm going to write it down first. I hope you guys are writing this down. What does that make n on the left side? Good.
3 root 5.
Okay. So people put that in the chat box. These are the same. They're going to be equal. So this is also 3 root 5 because that was my n. What do I put in place of this n?
3 root 5.
3 root 5. Because these are all the same. So wherever I see this in, I'm going to put the 3 root 5. So 3 root 5 times root 2. And what does root 5 times root 2 give me?
10.
Root 10. So I have 3 root 10. And that would be my answer for the hypotenuse. Okay. There's one last part, and we'll do that one. Okay. Okay, so we've got n, and then root 2. Okay. I don't have n, so I don't know what they all have in common this time. This is the one that's a little more tricky. Okay, if you don't get this one, you have at least probably 80 to 85% already mastered. So don't stress so much if you don't get it yet, because you will eventually get it. If you don't get it yet, it takes practice. So this is my, try a different color. This is the one where my root 2 does not have a root 2. So what am I going to do?
Do the shortcut.
Yep. This is where I'm going to use the shortcut. Okay, so that means that I need to find n. So in order to do that, n is equal to whatever number that is with a root 2 over 2 next to it. Oops, sorry. So what is the value of the one that didn't have a root 2 next to it? This is the one labeled in root 2, but it doesn't have a root 2 next to it. But what is it?
9.
9. A couple people put that in the chat box. This is the value that's going to go right there. That's going to allow me to find n. So I'm going to put 9 right there. Does 2 go into 9 evenly?
No, so it's just 9 root 2
Over 2.
over 2, yeah.
So this becomes my whole n. So this is 9 root 2 over 2. What does that make the other side?
9 root 2 over 2.
Yep. 9 root 2 over 2, because these are equal. Okay. All right. So that's as complicated as they get. Okay. Sometimes they have different things. I mean, like this could have been a 9 root 6, and then you'd still simplify. It's the same process. They may have slightly different numbers. Okay. But it's the same process. So anybody want me to zoom out so they can take a picture of this? Okay, there was a couple. Maybe that. I really don't like that line there, but okay. So go ahead and take a picture of that. So let's go back to our problems. We were on number 15. Okay, so back out. So if my left side is root 2, what does that make the bottom?
Root 2.
Root 2. They're all the same. These two are equal. That makes that root 2. What do I do to find the hypotenuse? What am I going to put in place of n?
Root 2.
Root 2. Yep, because these all have the same in common. This n, that n, and that n are all the same. So I'm going to simply substitute that n into n. So I'm going to have root 2 times root 2, which gives me what?
2.
2. So this is going to equal 2. Okay. And then last, for the 45/45s, labeling, I have n, n, and n root 2. And what do they all have in common?
The n.
The n. So what is my n?
7 square root 2 over 2.
Good. This is my n. So what does that make the left side?
7 square root 2 over 2.
Good. Okay. I'm only hearing from a couple people, but I need to know that everybody's getting this. Okay. So if you can you can even put it in the chat box. I'm getting it, still don't get it. But remember, these all have the same n in common. So what am I going to put in place over there for the hypotenuse? Does it change just because it's not a nice number? Thank you. If this were 7 down here, guys, this would be 7, 7, and what? Okay. If this were just 7, we'd be plugging in a 7 with a root 2. But it's, okay, let me get a little silly here for just a second, okay? If this were a giraffe, this would be a giraffe. This would be a giraffe root 2. Okay, if this were a banana, it'd be a banana, and a banana root 2. Whatever it is, whether it's a nice integer or an ugly radical fraction, it's going to do the same thing. So you're going to, you're going to write this over there, and then you're going to substitute that, whatever it is, right there for n. Yes, we need to do a little bit of work to that because we don't usually know what that is off the top of our head. So we're going to go 7 root 2 over 2. That's my n. Then I'm going to put a root 2 next to it. And then I have to simplify. And honestly, guys, you don't get a lot of these. I don't really do that to you. We need to practice it. But I'm not out to get you on these, okay? You just need to know, can I simplify? So there's my banana, root 2. There's my giraffe, root 2. So simplifying, what is root 2 times root 2?
2.
2. This is going to give me 7 times 2 over 2. Now what happens?
It's 14 over 2, which reduces to 7.
Good. And we could also say that the 2's can cancel, which is equal to 7. So my final answer here would just be 7. I'm hoping this is making a little bit more sense. Some of you are putting in the chat box that it does make a lot more sense since we did the detour. But think about it. Get a little silly. If this is a giraffe or an orangutan, this is an orangutan. That's an orangutan too. Doesn't matter. Okay, so now let's go back and do the 30, 60, 90 triangles. I'm going to pause for just a second and get rid of that line because it's actually kind of driving me nuts. So let's go back to do our 30, 60, 90 triangles. So we're going to draw that on our paper as well. Let's draw it here. I'm going to put a big box around that one. And let's put a box around this one. So that's a 30. And remember, opposite our 30 is what? What side do we call it?
Wouldn't that be
That's
N?
It's in. Okay, this is in. That's my smallest side. And then the hypotenuse is what?
2N?
N. And the long leg?
And root 3? Yeah.
Perfect. Okay, so we're going to put a box around this one. So now we have both. This is my 45, 45. This is my 30, 60, 90. So if you don't have both of these together, take a picture, put them on the same paper. So that now we can, look at these as well. Anybody still writing? So that detour that we did goes for this too. Okay. It's the same idea. But let me ask this. What do they all have in common now? What do they all have in common? Okay, a couple people put it in the chat box. They have in common N. Good. So they all have in common N. I'm going to do the same thing again real quick. So this is 30, 60, 90. There's N, 2N, and N 3. They all have in common an N. So look at the different relationships. In order to get from N to the hypotenuse, what do we have to do to it? What do we have to do to that number? What's in front of your N?
2.
2. Okay, so what does that mean I do to N?
Multiply it.
Multiply. Okay, this is an action. I'm going, just like over here, Or like in the last one, I had in, and in root 2. These are both actions that I have to do. So whatever number this is, they all have in common. All I need to do is write it here and multiply by 2. That same in, all I have to do is write it here and put a root 3 next to it and simplify. So if I've got, let's put an example over here. If I have 8, this is in, 2n, and in root 3. So this is the number that it's all about. So what am I going to do to this number to find the hypotenuse? What did we just say we were going to do to it over here? Okay. If I plug this in place of n, if I plug it or substitute it in to n, I have 2 times 8. What is that? Come on, guys. Okay. Let me put it in the chat box. Somebody say it out loud.
16.
16. Okay. And then over here, what am I going to put in place of n? Just like we did on the other one.
8.
8. I'm simply going to see these n's are all the same. I'm not going to put anything in for n that's not the same. So I'm going to plug an 8 into there and have a root 3. So this is the same, and that's the same. And that would be my answer. Done. Was there a lot of math to do? No, it was mental math. I take this in, I substitute it over here, multiply by 2. Done. Take this in, substitute it right there, write a root 3 next to it. Done. So going back to being silly, if my n is a giraffe, I have giraffe times 2. And over here I have a giraffe root 3. Okay, that's it. So I'm going to do one of each, then we're going to get back to our problem so we can finish on time. Okay, so 30. Let's call this one 14. Okay, so this is n, 2n, and n root 3. Most of you, I think, can do the mental math. If I know that 2n equals 14, what did I have? What was n?
7.
7. Okay. Remember this hypotenuse? It has to be the bigger one. So that means I'm going to take and divide by 2. So 14 divided by 2, and I get 7. That is my n. That's what they all have in common. That's what this is. 2 times 7 gave me the 14. So n is 7. So what is that going to give me for the right side or the long leg?
Seven root 3.
7 root 3. Yep. So I'm going to plug that in right here, and I have a 7 root 3, and I'm done. Or 7 root 3. Okay. Just plugging in my n. They're all the same. And last, 30. These are the 3 most common. Okay, if I tell you that this is 4 root 3, now, yes, they do get a little more complicated, but I really need you to see that whatever n is, all we're going to do is plug it in. It could have a root next to it. Okay, so labeling, I have n, 2n, and then root 3. So in the chat box, tell me what n is. Tell me what n is. There's 24 of you guys. I need to see it. Good. So far, everybody in here has it that's replied. Okay. So if they all have the number in common, this number, that number, and this number, it's the number next to the root 3. And yes, it's 4. So this equals 4. What does that make the hypotenuse? Somebody say it out loud.
8.
8. Nice. Because it's 2 times 4, which is 8. Okay. Those are the basic ones. Just recognizing what you do to get in. Yes, they do get some more challenging, but I'm telling you guys, if you can at least understand these 4, okay, you're halfway there, or 3 actually, okay? You're more than halfway there. The rest of it is just, okay, maybe my n had a root next to it, okay, or maybe I have to use a shortcut. Okay, let's go back to worksheet. Finish this up. Not that one. There it is. Okay. So number 4, labeling our triangles. This is n, 2n, and then root 3. Okay, guys, so what's n? Just say it out loud.
7.
7. Okay. N is 7 because it's the one next to the root 3. So that makes this 7. What does that make my hypotenuse?
14.
14. So 2 times 7 is 14. And you're done. Okay. Number 5, same idea. This is n, 2n, and then root 3. What's n?
I have a question
Yes.
on number 4.
Okay.
I thought that the n root or whatever always were like on the top, if you know what I'm saying. Like always was across from the right angle.
No. Across, okay, so on the 45-45 triangle, it had the root in the hypotenuse. So look at these for a second. This one has the root in the hypotenuse. This one does not.
How can you tell like which one's which though?
Because of the angles, this has a 45-degree angle. This one has a 30-degree angle. So it depends on what your angle is as to what picture you're going to look at.
Oh, okay.
Okay. Good. Did that help? That's why we chose to do all of the 45-degree angles first, and then go back and do the 30, 60, 90. You guys, so what's in on number 5?
5.
5. Okay, so n is 5. What does that make the hypotenuse?
10.
10. Because 2 times 5 is 10. And you're done. Okay. Now, we do need our 30-degree angle. If we don't see a 30-degree angle, we only have a 60, the other one is 30. This is where does get a little more challenging because they're not as nice as the other ones. So n, 2n, and n root 3. Remember we said sometimes our n won't be a nice integer. Sometimes it'll be an ugly fraction. Sometimes it'll have a root. Sometimes it'll have both. So what is n in this problem, number 6?
Two root 3.
2 root 3. Good. Okay. 2 root 3. This is my n. And wherever I see an n, I'm going to put right there. I'm going to substitute. So we're going to substitute right there. I go 2 times whatever n was or is 2 root 3. What is 2 times 2 root 3?
Four root 3.
Nice. 4 root 3. Okay. And there's your answer. What am I going to substitute for that n up there?
Two root 3.
2 root 3. Yep. So there's my 2 root 3 with a root 3. What is root 3 times root 3, people?
3.
3. This is 2 times 3, which is 6. And you're done. Okay. Please don't let the numbers themselves trip you up. Okay. It's the process. It's the process. My giraffe is 2 root 3. I'm going to put 2 root 3 right here for n. My n is here. I put my giraffe, which is 2 root 3. Okay. Let's do number 8. Okay. So we've got, this is my 30-degree angle. This is n, 2n, and n root 3. Okay, let me do this. Let me do a little what if. What if the hypotenuse were 20? What if the hypotenuse was 20? What would my n be?
10.
10. Okay, all we did was divide by 2. So we're going to take this number and divide it by 2. So this is going to be 4 root 6 divided by 2. What is 4 root 6 divided by 2?
2 root 6.
2 root 6. So 2 root 6 is my n. That's my n. See? If you get stuck on a problem like this, make up a nice number like I did. If this were 20, what would I do to find my n? And you're like, I would divide by 2. And it would be 10. So that's how I know what I need to do. Okay, so that's a 2 root 6. So what goes right here in place of that n?
2 root 6.
2 root 6. So 2 root 6 times root 3. Okay, and I need to simplify that. So I can multiply inside numbers together. I get an 18. But we know that that can simplify. And I could have actually broke it down right here and it would have been easier. But I don't know that all my students would have done that. So we have 2. What is 18? What goes into 18?
9 times 2.
9 times 2. What's the square root of 9?
3.
3. So 2 times 3. The leftover root 2. And 2 times 3 is 6 root 2. And you're done. But again, guys, it's the process. I had my hypotenuse, I divided by 2. I found n. Once I found n, I plugged it in next to my root 3, multiplied it by root 3, and simplified if I could. That's all there was. Anybody still writing? Flip it over. We're gonna do some that maybe are a little more challenging first. We'll go back to the others. Let's do number 11. So here's my n, 2n, and n root 3. Okay. So what do I do to the hypotenuse to find n?
You have to put 2 root 2 next to 5 to do the shortcut.
If I were doing the 45-45 triangle, absolutely. Okay, but remember, we're doing the 30-60-90 triangle. So that's why I labeled it the way I did. If the 5 were over here, then I'd have to do a shortcut, but it wouldn't be root 2, it'd be root 3. So, okay, let me ask this. If this were a, let me go back to the 20. If this were a 20 instead of a 5, what would n be?
10.
10. Okay, so all I have to do is divide this by 2. I'm going to take this number and divide by 2.
Can't you just do substitute 5 for n and do 5 times 2, which is 10?
No, because then you change the value, because what actually happens is 2n is 5. It's not that we're substituting 5 for n, it's that 2n is equal to 5.
Oh, okay.
Okay, that's why we need to divide by 2 to find n. So n is 5 over 2. What do I do with my 5 over 2 now that I have n to find the long leg? What do I have to do to find the long leg?
5 over 2 times root 3.
Yep. All I have to do is simply plug it in, and I'm going to get 5 over 2 with a root 3 next to it. And there's my answer. Okay, let's do 17. Okay, so here's my 30-degree angle and labeling. I have n, 2n, and n root 3. Okay, so in the chat box, tell me what n is. Tell me what n is. And this will be our last problem. Okay, most everybody has it so far. And if you don't know, please be honest and just say IDK or I'm not sure. I really need to know still. Okay. Some of you have a question mark, but that's okay.
Wait, what are we finding?
N. Okay. These n's are all the same. Okay. I know that this 2n is equal to 10. Some of you are drawing the wrong picture. You have to be using the label for the 30, 60, 90 triangle. There are two special triangles, and you're going to know which one to use because this is a 30 and a 60, not a 45 and 45. Okay. So if I know 2n equals 10, then what does n have to be? Let me say it out loud.
5.
5. If I divide both sides by 2, n equals 5. And what do I do with that 5 to find the long leg?
You put 5 into n, so it's n, or it's 5 square root 3.
Perfect. And nicely said. You put the 5 in for n, and you put a root 3 next to it. So we end up with a 5 root 3, and you're done. Okay. I know some of you are still struggling, and I understand that. We're going to use Monday to go over problems from this week. I still need everybody to check in, even if you've done the assignments. But after that, if you've done the assignments and turned them in, you're free to go. And I'll work with those that are still left. So that should be an incentive to get everything turned in. Any questions before you go? Okay. I will be at tutoring today and tomorrow. Today is from 3:30 to 5:30 and tomorrow is from 2 to 5. So if you're still struggling, I would encourage you to come by and for after school tutoring.